Welcome to this walkthrough of Cronos on HackTheBox. This is the third in our series of 10 machines exploited without the use of Metasploit, wherever possible. As usual, check to make sure that we're connected to our network. We are. And we'll begin with an mmap scan employing the available scripts, getting the versioning information on all TCP ports on this machine. If you're following along, you can pause now and restart again, and we'll return when the results are back. All right, and our results are back. So we can see that we are looking at an Ubuntu Linux server that's running SSH, port 22. It's running DNS, port 53 is open, and port 80, so some sort of HTTP web service. And if we browse to the website, we can see that we have an Apache 2 for Ubuntu server. We're looking at an Apache Ubuntu default page, which it shouldn't be showing up if there is any content. We can see that it's running DNS, of course. So we can have a look at what information that will give us about the website, the system in general, if we run NSLookup. We can set the server that NSLookup is going to query. We can provide it with the 10.10.10.13 server, and then we can query it about itself, which shows us that it's serving up DNS for the Cronos.htb domain. So with that information, we can query the DNS server a little further and use a different command, dig, to attempt a zone transfer. So the ability to perform zone transfers, that is replicating and updating data between DNS servers, it's a normal aspect of network administration. If it's not restricted to safe DNS servers, though, we can leak information about the network. So if we use dig AXFR, which is the record type for zone transfers, provided our IP and domain, then we're provided back with the records from that DNS server. So the zone transfer was successful in this case. So we have a full set of DNS records from the server. It tells us that it should be serving up www.cronos.hackthebox, or HTTP, as well as this admin.cronos.htb site. Now when we try to browse to Cronos.hackthebox, we can see that it's trying to load, but if we sit here long enough, we'll get nothing returned back. The page simply doesn't resolve. The same is true of admin.cronos.hackthebox. Blank page, no resolution. So the DNS entries are there, but they may not be doing their job for some reason. We can achieve their intended functionality by simply adding entries to our local Etsy hosts file. So if we add in lines for www.cronos.htb and admin.cronos.htb, then we're performing the same job that the DNS server was supposed to do, only we're doing it locally. And as you can see, eventually it'll come back unable to find the site, unable to connect to the server at that address. With those entries in place, though, we can run that again, and now we get the site resolving. And if we pick through this, it's a simple site. It's a series of pages of documentation and other resources about the Laravel PHP framework. Not much help to us here. But we do have that admin, and if we browse there, then we get a login page. So this looks like a simple form. A good test for any login form is to see if it's vulnerable to SQL injection. That is, can we trick the SQL database that's being queried by the login form? Can we trick it into logging in without valid credentials? So for this, we're going to need to grab a couple of extra tools. So we can grab a list of test strings for SQL injection from Daniel Miesler's seclists repository. As you can see, he's got lists in here for just about everything. Going to fuzzing, SQL injection. We can just have a look at the generic list for now. And you can see there are 260 lines of test strings for a variety of different possible SQL injection entries. So we can just go to the raw, copy that list. We could try all of these manually, which would be painful and slow, or we can speed it up a bit using the intruder module in Burp Suite. So I'll just load that up here. Burp Suite is a web proxy, so all of the traffic to and from the web server passes through Burp. And that lets us intercept and modify requests between the time they leave our browser and the time they arrive at the web server. So that means we can do things like bypass local restrictions that are running as JavaScript in our browser. But in this case, we just want to send and resend the same request with slightly different data. Now, in the latest versions of Burp Suite, there is a built-in Chromium browser accessible from the proxy tab. That appears not to work properly in the current version of Kali due to some permissions, sandbox permissions. But we can get the same functionality out of our Firefox browser just by setting the proxy settings. So if we go into Preferences, search for proxy, get the proxy network settings, and rather than having it set to no proxy, we set it to a manual configuration of 127.0.0.1 on port 8080. So with that switched over, now all of our browsing is going to pass through this web proxy. So we've got our intercept turned on. We can intercept all of the traffic that we see. So we simply submit a login form with any old credentials, user, pass, and it will intercept our request. So this is what the request to the web server looks like for submitting that form. It's a post request to the admin.cronos.htb site. And the content of it really is just the username equals whatever we've entered, and password equals whatever we've entered. So we want to send this to the intruder module. So we just right-click on our packet, send it to intruder. Intruder lights up in the list of tabs. We can see that in this we're attacking admin.cronos.htb. So in intruder, we define the part of the request that we want to modify each time. We'll start by clearing out the auto-detected parameters for modification. We'll just add our own, in this case just for username. We'll just highlight our inputted user, click add, and now our payloads will be placed into that position. We'll leave it on attack type sniper. So this is affecting just one parameter. There are other modes, pitchfork for example, if we wanted to test a list of leaked username and passwords together in parallel, or cluster bomb mode, if we wanted to test multiple parameters in combination, so brute forcing all of the possible combinations of a set of parameters. Here though, we just want to use sniper, just one parameter that we're working with, the username, with our list of SQL injection test strings. In the payload, we can see that we have one payload available to us, one payload area that we've made, and we're going to keep it on simple list. And we're simply going to paste our list of SQL injection strings that we copied from Daniel Miesler's sec list into our payload list. With that ready, we can simply hit Start Attack, accept the notification that it's going to be rate limited. This runs much faster in the Pro version of Burp. Community Edition is rate limited, but our list isn't too long, and we can see the results coming in at a reasonable rate. I'm simply going to sort this by length. What we're looking for is a different length, probably a longer length if it logs us in correctly. We could search by status as well, looking for a redirect to say that we are indeed being redirected to a different page because of the login, rather than a status 200, which simply is the server returning the current page with the information saying that it's unable to log us in because we have an invalid username or password. So we'll sit with this for just a moment and pause if you'd like while your results are running, and we'll be back in just a moment. And we're back, and in this case our result was actually shorter than expected, but we do see our status 302 redirect. And in this case the payload that worked was admin single quote or single quote. This in the username field. So we can close our intruder and indeed our whole burp proxy. Reset our preferences. To no proxy. And browse normally. And if we were to provide in our username admin single quote or single quote and submit, we are logged in. We've bypassed authentication completely. Here we see the welcome.php page. So this page has a NetTool version 0.1 that apparently can run traceroute or ping on an IP that we're meant to provide. Now this box isn't connected to the internet, so it can't actually ping or trace out to anywhere. Google DNS at 8.8.8.8 is a good test, but we can't connect to it. But we are able to inject commands here. So if we use pipe character and provide an additional command, say cat etc password, it returns the contents of etc password, which we can see is shadowed. We could try piping cat etc shadow, but it's not going to return any results. We don't have permissions at that level, so we're not root just yet. We can find out what user we are running as using the whoami command, and apparently we're running as www-data, common enough for the web server to be running as. If we see if that server is running has netcat on it, it certainly does, so we could try to get a reverse shell using netcat. First we want to set up our listener on port 9999, and if we run our netcat command, connecting back to 10.14.14 and executing bin bash, it appears not to work. We don't have a connection on our listener just yet. Maybe it's that www-data doesn't have execution privileges on netcat, but we do know the server is also capable of running PHP. And www-data is most likely able to run that because we're running, we're on the welcome.php page right now. So if we have a look in the payload all the things, repository. We look for reverse shell cheat sheet. Then we will find a reverse shell command, series in fact, of reverse shell commands for PHP. So if we select one of them, we return to our net tool. Our listener is still open. We've got our command ready to go. It's going to create a socket with 10.10.14.14 on port 99 and execute bin bash. And this time we do get a shell running as www data. So navigating to the home folder, we can see that there's a folder for a user called Nulis. And we have permission to list its contents. It appears everyone has read permissions on the user.txt file. So we should be able to cat out user.txt. And we can. So we've got the contents of the user level flag. But we can't cd to the root directory. And we can't cat out root.txt. Permission denied. So let's get some help to escalate privileges. So if we navigate locally to our payloads directory and our lin enum directory within that on our local machine, then we can run our Python simple server, simple HTTP server. So that's serving up the contents of that directory. And then on our remote machine, we can go to the temporary directory and grab the lin enum script that's being served up by the HTTP service. And then we see we got a GET request for it, and we have successfully saved it remotely. So we'll change permissions on it to executable. And run the script. And it'll take, as usual, a minute or two to run through all of the testing that it does to see what's available to us for privilege escalation on this Linux machine. We have a small problem at this stage in that it exceeds the length of our available history on this machine. So we can't see the entire contents of our lin enum output. One solution for that is to run the script again and redirect its output to a file, output.txt. I'm going to run that again, as can you if you'd like. I'll be back in just a moment when the results are back in that text file. All right, and we've got those results back now. We're going to have to look at it in sections using the head command. 100 lines at a time is fine, so we could go 100, 200, 300, and look at them bit by bit. So this is giving us the first 100 lines. What's going to give us the most important information in this particular case is down around 300 lines. And scrolling up here, the thing that really stands out for us is this result, the cron tab contents. So the cron tab is running scheduled tasks, essentially. And in this case, what's happening is that the file in /var/www/laravel, the file called artisan, is running every minute of every hour of every day of every month, every day of the week. That's what the stars indicate, the frequency in minutes, hours, days of the month, months, days of the week. Set it across that way. And it's running as root. So that may be useful to us. So if we were to list out using the -al option, var www laravel artisan, we get back the permissions, and we can see that the owner has full read, write, and execute permissions, and www data is the owner. If we were to cat that file out, we can see that it's a script running some PHP code for us. So as polite intruders, we'll copy the artisan file, so that we can replace it later, because we're going to replace artisan's contents now with our PHP code to create a new reverse shell. So before we do that, we'll set up another listener. On a different port this time, just in case we need access as www data again. So we'll set it up on 9990 this time. And here we're going to echo to that file the start of a PHP that's going to open a socket on 10.10.14.14, port 9990, which is our listener, and it's going to execute bin bash in the interactive mode. And we're sending that to be the contents, the new contents of the var www laravel artisan file. And we can confirm contents. Of our file. So now it looks like a regular PHP file. We know from our cron that this is going to run PHP, and actually it's just waited a minute, and we have our shell. So if we run now, who am I? We can see that we're running as root. So when the cron tab's scheduled task runs, and when it runs this artisan file, it does so as root. So it opened the shell as root. And we can cat root root.txt. And there we have our root flag. And then to clean up, we'll simply move our copied file back into the position of the original. So that's the exploit path for Cronos. We begin with a DNS server that allows zone transfers, which it ought not to do. That should be restricted to specific DNS servers that need to replicate and update data between them within the domain, rather than just anyone who can connect to it. That gave us information about the website that was temporarily broken. It gave us the address of gave us the URL for the admin.cronos.htb site. Once we were in there, we were able to make use of a list of SQL injection test strings. That form should have been, at the very least, limited in the number of attempts that it would take over a period of time, so the frequency, as well as the number of attempts, number of wrong attempts that it would accept before locking the user out. Ideally, that request should also be handled by a safe API rather than being a direct query to the database. Once we got past that, we were presented with this incredibly vulnerable net tool. So it is a very bad practice to provide the user with the opportunity to inject commands directly to the operating system. This sort of functionality should be taken up entirely within the tool itself. That allowed us to open up a reverse shell, and once we were in, we have the ability to have a look at the cron tabs. We can see that there is a file that we as www-data have full read, write, and execute access to, but which is being run as root every minute of the day. That allowed us to replace the contents of that artisan file with whatever we want, in this case an additional reverse shell, and that shell will be run as root.